Good day, folks. Welcome back to Ed's Garage. Today I'm at home and I've got an exciting little project to work on. Today I want to basically take apart and talk about the ICCU on the Hyundai lineup of electric vehicles. So this part right here is used in, or a variation of it is used in pretty much every current Hyundai electric vehicle. As you can see here, it says ICCU assembly. Now this is also used in Kia products and Genesis products. This is part number ID E111A1XA, HMC Hyundai Motor Corporation part number 364001XAA0, and it's originally made by Mobis. Mobis being Hyundai's subsidiary that does this sort of thing. So the reason that we want to talk about this is because it's a bit of a contentious issue. The ICCU has been failing on Hyundai electric vehicle products, unfortunately, for a number of different, a couple of different reasons. So there are two main failure points of the ICCU. One of them has to do with coolant. As you can see, you got the coolant lines running in here. Coolant leaking onto the internals of the ICCU, and the other is an overcurrent, which is basically causing a fuse to blow. So this ICCU, I'm not sure exactly what it failed from. That's what I'm hoping to find out after disassembly or during disassembly. But I want to talk about the main sort of causes for these things. So one of the causes, the leaking of the internals, is due to some failed welds inside there. So it's made of aluminum, so I'm guessing they're talking about failed aluminum welded points within the coolant channels or something like that. And then the other failure is from overcurrent, basically a surge of electricity or something like that. Now, this is a bit of a contentious topic because the recalls to prevent this problem have consisted of software updates that basically reduce the overage of current, the amount of current that's flowing through the ICCU. So they reduce your AC charging rate, which can be up to 11 kilowatts. They reduce it down to whatever's necessary to get the temperatures of the ICCU and the charging port. The recall also does the charging port as well, reduces the temperature of that by reducing the current flowing through everything. Now, it is my firm belief that if you were to charge at 16 amps, 240 volts, basically 3.6 kilowatts around there, that you probably won't experience this problem. Now, some people may have, some people probably already have, probably the weld issue, not so much the overcurrent issue. It's always been my recommendation to charge at 3.6 kilowatts if possible. And the reason for that is because 3.6 kilowatts will regain you about 200 kilometers of range every night. So if you're driving, if your day-to-day driving is less than 200K per night, or per day rather, then 3.6 kilowatts should be plenty. And even if you come back with a dead battery, you plug it in, and sure, it might not be full the next day, but the chances of you needing to go another 400 kilometers the next day are pretty slim. Let's be realistic. So charging at a lower rate is going to be better for the ICCU, technically better for the battery in the long run, but probably isn't going to make a huge amount of difference. It's easier on your house. So what I mean by that is if you have a low amperage house, so if your house is only rated for 100 amps, your breaker box is only rated for 100 amps, and you're only pulling 16 amps, well, then you have a lot left over for all of your other stuff. And if you think about it, if everyone, is going to be required to be driving EVs in 20 years, if everybody's charging at high rates of speed in the evenings, that's going to put a load on the grid that the grid might not be able to handle. So by that time, I'm sure it will. I mean, that's a bit of a myth that I think anyway, it's going to be overcome pretty easily. But anyway, if everybody's charging at only 3.6 kilowatts, then it's going to be much easier on the grid. So it's easier on the grid, it's easier on your house, it's easier on your car's battery, and it's easier on that ICCU. Now, a lot of people are shaming Hyundai, saying, well, that the software update isn't actually a fix and that, it should be able to handle the 11 kilowatts that was promised. And yeah, there's some truth to that, but there's also some truth to you know, that this is a fix. And what I mean by that is vehicles that have the capability of charging that fast, other brands don't necessarily charge that fast all the time. They're throttling back the speed as well. So this is a fix in that it should have been like this right from the get-go, and the advertising basically was, you know, can charge up to 11 kilowatts. So take it however you like it, or however you want, but I don't think it's a big deal. I don't think having to charge at 11 kilowatts is necessary for 99% of people out there. Anyway, without further ado, let's have a quick look at this ICCU and see what's going to be involved in disassembling it. So along the edges we have T25 Torx screws, so I'm going to go ahead and use a Torx bit for that. We got 4 little bolts here. They are 8 millimeter by the looks of it. Yeah, it's 8 millimeter. So there's 1, 2 here, and then 2 down at the bottom here. So on the outside we have connectors here for what I assume this is the high voltage, the 800 volt output. And then right here we've got smaller pins. My guess is that's probably the 120 volt output for vehicle to load, but I could be wrong. And then I'm also guessing that this is going to be our 240 volt input. From what I understand, this doesn't have anything to do with the DC fast charging. That's more of a direct connection to the battery, whereas this takes your 110, 120 volts, ups it up to the 800 volts of the battery pack, which I assume comes out this end and then charges the battery. Right here we have a pin for, a pinned connector for all of the software controls for that. Now, before I get too far into this, guys, if you find this interesting, please don't forget to like and subscribe and comment below if you have any questions that I may or may not be able to answer. If you do enjoy this type of video, you should check out Ed's Automotive How-To, my other channel. You can find that within the information within this channel. I'll link some things in the description below as well, because right now I'm actually in the process of disassembling a huge battery pack from a 2015 Chevy Spark Electric. So you can see all of these cool packet cells. They're actually very similar to what a Hyundai uses. They're from LG Chemistry. And as you can see, I've actually got a total of 6 modules. There's 5 right here, and then that was another one. These 5 are actually in really good shape. And I basically saved this battery pack from a recycling depot because I plan to use these cells for various projects. Anyway, let's start taking this guy apart. Now, before I get too far into this, I'd like to just quickly say, do not try this at home. There is capacitors in here that do hold a lot of power. I'm going to probably need to discharge them safely once I get this covered off. Also note that I'm not trying to save this ICCU, so pulling it apart, I'm not going to take it easy. I'm not going to be gentle. This is all glued on, so it's going to be a pain to get it open. These weren't really designed to be pulled open and repaired, which is unfortunate, I guess. But I mean, the design really was meant to be sort of a permanent thing. So it's going to be a bit of fun getting this open because there's a silicone sealant all the way around. All right, so first little bits come into view, and yeah, it looks like, you know, the smell inside of here is quite strong of ozone. So pretty interesting. The capacitors here are all transferring heat. This little heat transfer pad to the outer casing. All right, I just pulled off this cover right here from this little section, and thinking that there might have been some capacitance from some capacitors. I kind of went through and shorted everything out, even to the case like this. interestingly, check this out. So I dug down a little bit into this sort of the silicone mess down here, or whatever this is. This seems like heat transfer paste, and it's just all over the bottom. I see a couple of coils down here, as you can see in there. Obviously, this is the controller board right here because it's connected to the sort of control connection, and I would surmise that this is sort of the main board that does all of the switching. I'm going to go ahead and just start pulling all of these components out and discharging electricity as I go. Like I said, this wasn't meant to be a rescue attempt of this. Something smells really burnt in here, though. So basically what I'm just looking for is any signs of burnt circuitry or liquid from the coolant. So far, I haven't really seen any. It feels a little damp, but I mean, that could just be some of the residual, it's kind of hard to show this on camera, but over each one of these components, there's actually little bits of silicone. It looks like they may have even anticipated a possible failure point being coolant entry, because, I don't know if you can see that on camera, but there's kind of silicone covering all of this stuff. I guess maybe just in case little droplets of coolant got in here. So that's kind of cool. Not even on the bottom, not even on the top, it's on the bottom as well. So the circuitry looks very well protected from liquid intrusion. I'll take this other one out. Even the ribbon cables are extremely high quality. All right, so another cooling block here, just a piece of solid aluminum. You can see some heat transfer paste or pads, whatever you want to call them. Let's have another look here, guys. Check this out. So we have what appears to be a bunch of very, very high voltage relays. These are 900 volt capable relays. And then this little wiring harness goes into this thing, which we haven't opened yet. So let's open this up next. Alright, I've exposed the side circuit board here. Apparently this is a filter. I don't know what exactly it is doing. Maybe filtering out highs and lows and static and noise so that it gets a clean signal everywhere, I guess. Again, I am not an electrical engineer. I have just enough knowledge to be dangerous. That was a comment somebody had a while back on one of my other channels, and I love it. All right, check out those big coils. Cool. All right, so I've learned a couple things here. So we got some big coils, some relays on there. I can definitely see the output of the 800 volt DC. Check this out. Look at the size of these guys. Now, I have been going through and kind of just shorting everything out here just to make sure that, there's no excess capacitance anywhere. Mind you, this doesn't have any capacitors on it. It's all right there. So I'm about to take out this board, but I just wanted to show you what I see here. So I figured out that this port actually is the 12 volt out. So if you look down here at this little main board, it says DC out positive minus, positive negative. So that is what's charging the accessory battery. And then on this side, obviously you have your high voltage output, because it's massive. But then the little guys there might be the input for AC charging. So input and output, probably. And then, of course, going through all that stuff there. Yeah, this is called a filter board. So using those coils, I'm guessing it just filters out dirty energy, dirty sources, noise, that sort of thing. That'll go on the scrap heap. Also, this is kind of cool. Check this out. One of the little heat transfer pads. So that was basically, they're on top of each of the coils, and then going on to here, which of course is being cooled by the coolant. And actually, it's right next to the main coolant channel. Yeah, this is still like damp. I don't know what I could use those for, to be honest, but they feel weird. Still no like liquid anywhere, so it doesn't appear to have leaked into the unit. But yeah, let's take out the main board next. Okay, so you can see we have DC to DC, out, DC to DC, 1A or IA1, DC to DC, 1B1. Those were down here onto this board. So the part number on this board is M304200019843. Built in 2022, April 26th of 2022. And again, looking at this board, I'm not seeing any evidence of failure points. It seems dry. Got a little bit of that silicone on some of the contacts here, some of the ICs. Yeah, seems all right. Okay, now we're looking at the next board, M304200019824. And this one basically is connected to all of these pins on all these wires on the left-hand side here. Okay, let's start pulling some of these other screws out. Alright, so I just removed the big block with all of the thermal crap in there. So a whole bunch of thermal transfer grease on the bottom of this thing too. This is very heavy, whatever's in here. It looks like maybe just a bunch of coils. There's definitely some coils over on this side, some coils over on this side. So yeah, I would guess that there's just a bunch of coils in there. Weighs a lot. That might be the heaviest part of this thing that I've disassembled so far. But I look like I'm down to the last board here, which appears to have all of the, I believe they're all the yeah, I think all the MOSFETs are on the bottom here. I'm having a little bit of a trouble with one of the screws. It's being stubborn. Oh, there we go. Okay. And there is the last circuit board removed. And there... Just thermal stuff everywhere. Oh, those could come in handy. All right, so I just had to look it up because I wasn't 100% certain. These are actually rectifier diodes, not MOSFETs. So that's pretty interesting. All of them are directly mounted to the base of the casing, with a little bit of transfer tape stuff in between, and directly where the coolant channel is. So you can see the coolant channel itself is pretty basic. Comes in here, fills up this whole side, then goes around, fills up the... Sorry, I'm having a hard time here because I'm trying to hold this with one hand. So it goes in one side, goes around this, and then back out the other side. So this is very thin, but it doesn't look to have leaked at all. There's no sign of fluid anywhere inside here. But check this out. I did notice that it's the entire length of the bottom. And I guess, putting these things on these sort of blocks of aluminum help to transfer heat away from them, of course. All right, well, as you can see, that was the last of what was inside this ICCU. Now it's a very light box, just aluminum box with nothing in it. So, yeah, I still don't know what caused this one to fail. Didn't see any burn marks, it didn't even look like anything really got hot. Like sometimes you can see on a circuit board, certain areas are a little bit darker than others. In this case, everything looked great. I would bet that these circuit boards are fine. I don't know exactly what this one failed for. I'd have to go back and talk to the technician that worked on this vehicle. But apparently it was failed. And I don't see any sign of it at all. I mean, I do smell a lot of ozone. That's that burning electronic smell. But then considering how much power is going in and out of this little box, I don't find that entirely unusual or surprising. So I'm going to leave it at that. This was fun to disassemble and see what's inside an ICCU. But I will leave you with this. If you still think that Hyundai is not doing a good job at taking care of these things, just look at how complicated this piece is. And I will say this is an incredibly well-engineered component. Like, everything in this thing was packed in tight. It was clean. It was held together beautifully. All of the cooling and everything that I could see in here. Now, I was a technician for 17 years, and I've seen a lot of pretty poorly put together hardware. This is not that. This was incredibly well put together. And very, very well designed. Good use of space and good capability of cooling. I would have expected to see, with all that high voltage going through here, I would have expected to see some more, darkened bits here and there. This came out of a 2022, so it had been on the road for a couple of years at least, or at least a year and a half, I would say. And if I remember correctly, he said it had about 60,000 kilometers on it. So it had, it had seen some mileage. But it all looks really, really good. Anyway, I'm going to leave it at that. If you have any questions or comments, I will probably hang on to this stuff for a little bit. There's an interesting little plug right here, just noticed. So this pops out. So if you actually want to access the inside of the ICCU for whatever reason, there's a little plug here, maybe a breather or something. Anyway, if you have any questions, comments, please don't hesitate to put them down below. If you thought this video was interesting, don't forget to like and subscribe. And until next time, I've got a few more Ioniq 6 specific accessory videos coming up, so stay tuned for those if you're looking for some accessories for Ioniq 6. Otherwise, have a great day. Take care.